evaluate trigonometric function. So we are given here 7 secant square x minus 7 tan square x. We can take 7 common, right? So if we take 7 common, we get 7 secant square x minus tan square x. Now, what is secant square x minus tan square x? If you remember the Pythagorean identity, it is equal to 1. So since it is equals to 1, we get this is equal to this, which is therefore equal to 7. So this trigonometric function is equal to number 7. Okay, let me now show you once again how we got this, right? Now you remember the triangle which we made. So let's say that this is our right angle triangle where the angle is x. The opposite side is O, adjacent is A, hypotenuse is H. Now in this Pythagorean triangle, a square plus o square is h square, right? So we can write a square plus o square equals to h square, correct? Now to write it in terms of tan or secant, tan is what? Opposite over adjacent, right? So let's divide by a square all sides. So if I do divide by a square everywhere, what do I get? A square divided by a square is 1, right? O over a, opposite over a is tan and square. So it is 1 plus tan square x. And h over a is secant, right? A over h, adjacent over height is cos. And reciprocal of cos is secant. So it is equals to secant square x. So that is the trigonometric identity which we get in terms of tan and secant, right? So it can be rearranged, right? And it was secant, so I wrote sin it, secant square x. So it could be rearranged, and then we can take tan here. So we get secant square x minus tan square x equals to 1, correct? So that is what we use here. Secant square x minus tan square x left when we took 7 common, and secant square x minus tan square x is 1, right? And that's how we got it. So this trigonometric function is equal to 1.